In the previous chapter, we have find out the derivatives of the exponential function like this e power x, and we have obtained e power x. And similarly for this e power ax plus b, this comes out as a times e power ax plus b. So we take this as the e power x and then differentiate this part, and then a appears at this side. So this was the case, and now if we take this e power x as an integral, then we get e power x plus c, some constant here. Similarly for this e power ax plus b dx, then we get this e power ax here, and then ax is in the denominator. So this a part is here and plus c. So we will use this rule for this exercise 15.4. So this exercise, let's start this one. Here we have e power 5x dx, then we get this e power 5x upon 5 plus c. Similarly for 4 e power x dx, 4 e power x and plus c. Similarly for this 1 over 3 e power 6x minus 1 dx, then this 1 over 3 is here, and for this integral part it is appear as this e power 6x minus 1 then upon 6 plus c is a constant, and now simplify it, 6 3 the 18, and e power 6x minus 1 plus c. Now in the second part we have this e power x bracket 5 minus e power 2x dx, and we'll multiply this ex with each term and then expanded it like this. And now this term 5 e power x, for this term e power 3x divided by 3 plus c. Similarly for the c part, we have this 3 e power x plus e power minus x whole square dx. Now we'll expand this bracket and will appear as 9 e power 2x plus 6 e power minus 2x, and take this integral of this term. So this 9 will appear here, e power 2x divided by 2, this is 6x, and this part is e power 2 minus 2x divided by minus 2 plus c. Now we'll simplify it, 9 by 2 e power 2x plus 6x e minus e power 2x divided by 2 plus c. Now this f part, e power 4x minus 2 e power x whole square divided by e power 3x, this becomes, we expand the numerator, that is e power 8x minus 4 e power 5x plus 4 e power 2x, and the denominator we have e power 3x. Now we divide the each term by the e power 3x, and we will have this e power 5x minus 4 e power 2x plus 4 e power minus x. And now we'll take the derivative of each term, and this is e power 5x upon 5 minus 4 e power 2x divided by 2, 4 e power minus x divided by minus 1 plus c. So this is comes out as a 1 over 5 e power 5x minus 2 e power 2x minus 4 e power minus x plus c. And now let's solve the third question. This is again the integrals. Let's solve question number 5. A curve is such that dy by dx is equal to k e times e power 2 minus x plus 4x, where k is a constant. At point 2, 10, the gradient of the curve is 1. At this point, at the value of x and y 2, 10, the gradient of the curve, this curve is 1. At this point, if we place the value of x 2 here, then we have dy by dx as 1. Find the value of k and find the equation of the curve. So this is question number 5, and let's solve it. This is dy by dx equal to k e power 2 minus x plus 4x, k where k is a constant. At point 2, 10, dy by dx is equal to 1. dy by dx is equal to 1 when we have at point 2, 10. So 2, 10. So we place this 2 here, 2 here, and this is 1 is equal to k e power 0. This is 1 and k plus 2, 8. So k is equal to minus 7. So now place this minus 7 here. So minus 7. So we take e power 2 minus x and we take the integral of this. So this is e power 2 minus x divided by minus 1 because of this minus, plus 4, this is 4x square divided by 2 plus c. Now we have at 2 comma 10 we have this e value 2 and then y is 10. So we place this 2 here and 10 here. So this 10 is equal to 7 e power 0, this is 0, so 1, 10 is equal to 7, this becomes 7 plus 2, 4 to the 8, so c is equal to, this is 15, c is equal to minus 5, so in place of this we will write minus 5 here, so y is equal to 7 e power 2 minus x plus 2x square minus 5, this is the required curve of equation question number 5. Now let's solve question number 7. The point P 3 upon 2 comma 5 lies on the curve for which dy by dx is equal to 2 e power 3 minus 2x. So dy by dx is this, and the point 1 comma k also lies on the curve. This point is also lies on the curve. So find the value of k. The normal to the curve at point P and Q intersect the point R. P and Q intersect the point R. Find the coordinates of R. So this is very important question. Question number 7. So let's start this 7. So P is equal to 3 upon 2 comma 5 lies on the curve. This is the gradient of this curve. So point Q is 1 comma k also lies on the curve. So k is have to find. So dy by dx is given as this. So y is obtained as 2 e power 3 minus 2x dx. So y is equal to 2, and this one is 3 minus 2x in the numerator, and this minus 2 will appear in the denominator, plus c. So at point, so this is y, and we know that this is a point P is on the curve. So in place of y we can write this 3, in place of x we will write 3 upon 2. So this is in place of x we will write 3 upon 2, and this is 5 here. So as a result of this becomes minus 1, because this is e power 0, this is 1 minus 1, so 5 is equal to minus 1 plus c, so c is equal to 6. So in place of 6 we can write 6 here. So y is equal to minus e power 3 minus 2x plus c, and q is also lies on the curve, 1 minus 1 comma k also lies on this curve. So in place of this we will write k here and 1 here. So as a result, this we have k obtained as 6 minus e. So k is obtained as 6 minus e. Now normal to the curve at point P is 2. So normal to the curve at point P is equal to 2. So this is 2 given. So the normal to the curve is obtained as this, minus 1 over m, because this is gradient of the tangent. So this is, because this placing this cancels out, and this dy by dx is equal to 2. So this is m. So minus 1 over m is the gradient of the normal of the curve. So the normal equation is y minus y1, which is 5 here, and x1 is this minus 3 upon 2, and this is the gradient of the normal is minus half. So this curve is this minus 5 minus half x minus plus 3 upon 4. So y is equal to minus half plus 3 upon 4 plus 5. This 5 will be here, and y is equal to minus half x plus 23 upon 4. Now the normal to the curve at point Q is equal to 1 comma 6 minus e. So this dy by dx is equal to this 1 is here, and dy by dx is 2e. So minus 1 over e is minus 1 over 2e. So by placing this equation into this, and we have y minus 6 minus e is equal to minus 2 upon 2e x minus 1. Now from this equation we can arrange this like this. So on equating this 1 over this, and it becomes with this equation and this equation are the same, so we can equate it. Equating this one, this part y is because they are on the same equation. So from this we have obtained x is equal to this 4e power 2 minus e minus 2 divided by 2e minus x. On solving this, x value is obtained as this. So similarly, on obtaining this, the y value is placing in this equation in place of this, and y is obtained as this part. So the R point is basically 4e square minus e minus 2 divided by 2e minus 1 comma 24e minus 4e square minus 21 divided by 4e minus 1. So this is a very difficult one and important one. So this is question number 7. In the next session we will discuss exercise 15.